Welcome. Today, we're diving into AI-based process optimization with Dr. S.K. Singh. We'll explore how artificial intelligence can streamline complex workflows, improve efficiency, and unlock new potential in various industries. Let's get started and see how smart technology is reshaping the way we work. Let's start by defining AI-based process optimization. It's all about using artificial intelligence and related technologies to make manufacturing better, faster, smarter, and more reliable. We're talking about improving everything from product quality to equipment uptime and overall efficiency. This approach applies across many areas, from API and sterile manufacturing to oral solid dosage, biopharmaceuticals, and packaging. The key technologies behind this include machine learning, deep learning, predictive analytics, computer vision, digital twins, reinforcement learning, and natural language processing. Together, they help us unlock new levels of performance. When it comes to current regulatory expectations, agencies like the FDA are on board with AI innovation. As long as manufacturers can prove scientific validation, data integrity, traceability, change control, and risk management. Over in Europe, the EU's GMP Annex 11 sets clear rules for computerized systems. They must be validated, secure, reliable, and reviewed regularly. GAMP 5 introduces a risk-based approach to validation, tailored for AI systems, scaling assurance based on use and complexity. And ICH Q9 reminds us that AI decisions need to fit within broader quality risk management. Let's look at a concrete example of how AI transforms pharmaceutical manufacturing. Here, AI predicts the best reactor temperature during synthesis, cutting down impurities and boosting yield. But that's just one part of the story. Across the entire life cycle, from process development and technology transfer to manufacturing, quality control, maintenance, and supply chain, AI plays a key role. It helps optimize processes, manage knowledge, predict quality issues, and even forecast demand. This integrated approach is reshaping pharma production from start to finish. Let's walk through an AI-based process optimization framework that powers intelligent manufacturing. It starts with process sensors capturing data, feeding into the industrial Internet of Things. This enables real-time data collection, which AI and machine learning models analyze. From there, predictive analytics generate optimization recommendations. These can trigger automatic adjustments or wait for operator approval. Continuous monitoring closes the loop, ensuring the system adapts and reduces variability. The result is a smarter, more responsive manufacturing process that keeps improving itself. Let's look at how tablet compression optimization works in practice. Traditionally, the compression force is fixed, and the operator steps in only after something goes off track. It's reactive. Now with AI, the process is proactive. The system keeps an eye on multiple factors: weight, thickness, hardness, turret speed, even the environment. For example, if the target tablet weight is 500 milligrams plus or minus 2%, the AI spots any drift early. It then suggests adjusting the feeder speed automatically. The result: fewer rejects and a smoother, more reliable process. Let's talk about improvement, the real goal here. We see reduced variability, which means the process becomes more consistent. That leads to higher process capability, making manufacturing more robust overall. Before AI was implemented, the target assay was 100%, but the observed mean was slightly lower at 98.8%. The standard deviation was 0.4%, with specification limits between 98 and 102%. This sets the stage for understanding how AI can tighten those numbers and boost performance. Let's talk about how AI steps in to predict quality in real time. It constantly monitors key factors, things like critical process parameters, quality attributes, environmental conditions, and how the equipment is performing. Take API crystallization as an example. The AI looks at inputs like temperature, pH, mixing speed, and solvent ratio. Using this data, it predicts the crystal size distribution before the batch is even finished. The result: fewer batch failures and much better consistency. It's like having a quality expert watching over the process 24/7. Let's talk about AI for predictive maintenance. Here, AI keeps an eye on key signals, motor vibration, bearing temperature, pressure, power consumption, and flow rates. For example, if a reactor agitator's vibration slowly rises, AI can spot it early, predicting bearing failure weeks before it happens. This means less downtime, better overall equipment effectiveness, and lower maintenance costs. It's about catching problems before they become emergencies, saving time and money. Let's talk about digital twins, a powerful tool in manufacturing. A digital twin is a virtual model that mirrors a real process, constantly updated with live data. This lets us simulate processes, optimize batches, fine-tune HVAC systems, and dig into root causes when things go wrong. For example, a digital twin might predict that raising the drying temperature by just 2 degrees can cut drying time by 12% without changing product quality. Plus, it helps meet regulatory demands by supporting continuous process verification with a science-based approach. When it comes to challenges and managing risk, we rely on several key controls. We validate computer systems thoroughly, review AI models regularly, and keep human oversight front and center. Electronic audit trails help us track every step, all while following ALCOA Plus standards for data integrity. For example, after a major algorithm update, a validated AI model is requalified through formal change control and performance checks. But challenges remain, from technical issues like data quality and model drift, to regulatory hurdles around validation, explainability, and change management. Looking ahead, AI is reshaping pharmaceutical manufacturing in exciting ways. We're seeing autonomous manufacturing take hold, alongside explainable AI that helps us understand decisions. Generative AI is speeding up process development, while AI-assisted root cause analysis sharpens troubleshooting. Smart robotics and real-time release testing are boosting efficiency. Edge AI brings intelligence right to the equipment, and sustainable AI optimizes energy use. To make this work, we integrate AI within established quality systems, manage risks carefully, validate systems thoroughly, and keep data secure and reliable. Continuous monitoring and expert review keep everything on track. So, to wrap up, artificial intelligence is reshaping pharmaceutical manufacturing in powerful ways. By combining AI with established quality frameworks like GMP and ICH guidelines, we're not just improving efficiency and product quality. We're also strengthening compliance and risk management. But AI isn't here to replace our scientific expertise. It's here to enhance it. Together, they create a smarter, more resilient industry that's ready for the future. And of course, all of this happens within a strong regulatory and data integrity framework. Thanks for joining me today. If you want to explore this topic further or have any questions, please don't hesitate to reach out. I appreciate your time and attention, and I look forward to continuing the conversation. Thank you. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.